Hey guys, this is Miss Mo. This is number 42 of the final exam review for Math 300. Okay, it says use the order of operations to simplify the expression. Okay, order of operations is this PEMDAS hoopla from 41 that we were using. Okay, and PEMDAS says the very first thing you have to take care of is what's inside the parentheses. So let's take care of our business in the parentheses and then we'll move on. Okay, inside the parentheses are 3/4 plus 1/4. Okay, who does that make? Well, if the denominators are the same, and they are, then we just keep the 4 on the bottom and we add the numbers on the top. So 3 plus 1 is 4. And if we try and reduce this, 4 divided by 4 is just a 1. So all of this parentheses hoopla is now a 1. Yeah. And then what's the rest of the problem? Multiply dot 2. And then y'all know what that is. 1 times 2 is just 2b. Woo! Okay, another one. Number 43. It says Bellworth University has an annual budget of 1 3/8 million. And Melmac University has an annual budget of 1 7/16 million. Which university has the higher annual budget? Okay, so it says which university has the higher annual budget. Okay, well, let's look at our annual budgets. We have 1 3/8 and we have 1 7/16. We need to figure out which one is bigger. Okay, so it's kind of like we have 1 3/8 and then a question mark, 1 7/16. And in that question mark, we're going to figure out whether that 1 3/8 is bigger, or we're going to figure out whether that 1 7/16 is bigger. You get what I'm saying? Okay, so first, I don't really know how big 3/8 is, or 7/16. So let's try and turn this into Texas and then a common denominator. Okay, so let's use Texas. Okay, Texas says to change this mixed number to an improper, we say 8 multiply 1, 8, plus the 3 on top, 11, all over what we divided by, 8. Okay, now let's look at this right-hand fraction. Texas, 16 times 1, 16, plus 7, 23/16. Okay, it looks like maybe this 23 is bigger because it has bigger numbers, but that's not how we tell. First, we have to get the bottoms the same. So I need to be able to look at these numbers with the exact same bottom. So I could change this 8 to become a 16. That way they match. Okay, if I want to get that 8 to become a 16, what do you have to multiply by? 2. And you do that top and bottom. So now you multiply left to right, and 2 times 11 is 11. 2 times 11 is 22. 2 times 8 is 16. And then we still have that 23/16 from this right-hand Texas. Okay, now let's figure out which one is bigger. This 23 is bigger because it's bigger than 22, but we can't make that decision until we get both of the bottoms the same. So if I would have chosen this alligator ahead of time, I would have gotten it right just by accident. Okay, so we should pick the 23/16 is bigger. And that sucker was this, what the heck was it? Oh, it was this 1 7/16. So 1 and 7/16 is bigger. Who had the 1 and 7/16? 1 and 7/16. Melvac. So D. Yes. Okay, let's go to 44. It says state the phrase as a mathematical expression. Use X to represent the variable. Okay, that means we're going to take these words and translate them into numbers and symbols. Okay, well, first it says the difference. That means minus. So anything without a minus, let's cross it out. Oh, goodbye, D. You don't have a minus. Okay, now the two things we're supposed to minus, it says the difference between 9 times. Okay, how do you show times? You say 9 multiply dot. Okay, so we're definitely going to have a 9 multiply dot. Then it says a number. Well, we don't know what the number is, and we're going to use an X instead of the word number. Okay, so it says we're supposed to difference 9 times a number, or that means we're supposed to minus 9 times a number, or 9x minus. And what other thing am I supposed to subtract? The difference between 9 times a number and 11. So those are the two things I'm going to subtract. 9x and 11. Woohoo! B. All right, let's keep going. 45. It says find the numerical value of the given expression for x equals 4 and x equals 18. Okay, part A. This part that says find the numerical value, that means your answer is going to be a number. And then it says for x equals 4, that means we're going to take this number 4 and we're going to plug it into that letter x in the equation. So this says x equals 4. That's like saying x is the number 4. Because equals means is in math. Okay, so we have x plus 1 over 2. But instead of the x, we're going to put a 4. Because it says x equals 4 or x is 4. So we're going to have 4 plus 1 over 2. And then what does that make? 4 plus 1, 5 over 2. So let's see here. B's out, C's out. Oh, and D's out. Okay. 8. Okay. Number 46, it says decide whether the problem is an equation or an expression. Equation means you can see it equals in the problem. Expression means there's no equals. Get it? Equal, equation. That's why it's called an equation, because it has an equal, okay, anyway, so let's look for the equal sign. Oh, there she is. Okay, so this is an equation. Okay, let's look at 47. See if you see an equal sign. There's no equal sign. So that means it's an expression. So equals has to have, equation has to have an equal sign. Okay, let's go to 38. It says find the sum. Okay, well, you can try putting this in your calculator, or you might want to try and do this in your head. When two symbols are the same, so we have a negative 20 and a negative 13. When we have the same sign, as in they're both negative, then we add the numbers, like 20 plus 13, and that gives you 33. But then because they were both negative, we stay negative. So my answer is negative 33. It's kind of like saying, okay, if I were on a number line at negative 20 and I subtract 13, where would I go? I would go left 13. 1, 2, 3, 4. And I'd land at negative 33. Okay, so D. Or you could put it in your calculator. So when they have the same symbol, like negatives, then you add the numbers up in your face to get 33, and then you keep a negative on that 33. And that's because they were the same sign. Okay, let's look at 49. We need to do PEMDAS. PEMDAS says P first. Okay, well, P means do what's inside the parentheses. Well, if we look inside our parentheses, I just see a negative 5. Then I'm not telling you to do anything else with that negative 5. So this P from parentheses, it can mean parentheses, or it can mean bracket, or in college algebra, you'll see these weird squiggles. They're called braces. Okay, anyway, so for the P, we take care of what's inside the parentheses, but there ain't nothing except for a negative 5. So then we say, hey, are there brackets? And heck fire, look at these brackets. Let's go. Okay, I'm going to keep the 4 plus the same. But then let's figure out what this 2 plus a negative 5 is. Okay, when they're different symbols, like this 2 is a positive and this 5 is a negative. When they're different symbols, you subtract them in your face. Like the big number minus the small number. Like 5 minus 2. And that makes a 3. But when they're different signs, you write down the sign of the larger digit. So, which number is larger? The digit 2, that just means 2 things, or the digit 5, that means 5 something. What's larger is the 5. So, I'm going to tack on a negative to that 3. Or you can just put this in your calculator, because by now you should be able to use a calculator. Okay. Or when the symbols are different, you subtract them in your face, 5 minus 2, and then tack on the sign of the big guy, negative. Okay, now let's see, the only thing left to do is add these. Okay, well, let's look at these. I have a positive 4, because it's sure not negative. Okay, so we have a positive 4, and we have a negative 3. Okay. When you add different symbols, you subtract them in your face. 4 minus 3, 1. And you attach the symbol of the bigger digit. What's bigger, 3 or 4? 4 is bigger. So you attach the positive symbol. Whoa! Or just put it in the calculator. Either way, C. Okay, let's keep going. 50. It says your bank account has $76 in it. Okay. And then it says you write a check for $22, $20, and $37. Okay, some of you might not know what that means. When you write a check, the money gets minused from your bank account. Okay, so we had $76, but then we write a check to pay for our clothes at Ross. So we subtract 22. Then we write a $20 check to pay for our pillows from Big Lots. And that stuff gets subtracted too. These all get subtracted. Then we write a $37 check for like Shoe Carnival. So that gets subtracted also. So if you can't really see that, it's dirty. Let me write it maybe again. 76 minus 22 minus 20 minus 37. Okay, that looks better. Okay, then it says you deposit $28.19. Deposit means we put money back into the bank. So we add money to our bank account. So when you write a check, that money gets minused. When you make a deposit, that money gets plussed. So let's plus that deposit of 28 and plus that deposit of 19. And then let's go. And by now we can just put it in a calculator. And I got 44. Okay. And then it says, are you overdrawn? This is a positive 44. So that means, no, I'm not overdrawn. If I would have come out with a negative number, then I would say, yes, it is overdrawn. But we came out with a positive 44. So no, we did not overdraw. Overdraw means you used all your money and now you're in the negative and you owe money. Okay, let's look at 51. Find the difference. Well, we have a negative and another negative. Okay, we have a negative, subtract 15. Okay, so we are minusing two negatives. Okay, when you're minusing two negatives, if it's the same sign, it's like on number 48. Even though number 51 is missing that weird little plus sign in between, it's the same process. So when your symbols are the same sign, you add the numbers in your face. 7 plus 15, 22. And then you keep that negative. So negative 22. Okay, let's look at 52. It says negative 8 minus negative 6. Well, anytime we see two negatives, those become a positive. So these two negatives, even though they're split by a parentheses, it's still okay. So this becomes negative 8. Then that double negative is now a plus 6. Okay, let's think about this. When they're different signs, you subtract them in your face. 8 minus 6 is 2. And you keep the symbol of the bigger digit. Okay, this 8 has a negative on it. This 6 has a positive on it because of that plus sign. So, I subtract them in my face, 2. Then I tack on the symbol of the bigger digit. 8 is bigger, and it has a negative, so tack it on. Or, if you're thinking about a number line, it's kind of like negative 8 is here, and we're going to add 6. So we go to the right. 1, 2, 3, 4, 5, 6. Until we land at, let's see, negative 8, negative 7, 6, 5, 4, 3, 2. Until you end up at negative 2. Ha ha ha. Okay, D. Alright, let's look at this sucker. It says, after one round in a card game, your score was 18 points. Okay, so we started with 18. After the second round, actually, let me maybe write this a different way. Okay, so round 1, you have 18 points. Round 2, we have negative 6 points. And it says, how many points did you lose in the second game? So how do we get from 18 to negative 6? It's like saying 18 subtract who gives you negative 6. Okay? Well, it definitely has to be bigger than 18 to give us a negative number. So, if I have like 18 minus 20, it would be equal to negative 2. 18 minus 21, it would be equal to negative 3. 18 minus 22, it would be equal to negative 4. You get the point. But 18 minus 24, that would be negative 6. So if you wanted to, you could just play in your calculator and say, okay, 18 minus 1. And we're supposed to get negative 6. So it's not 18 minus 1. Or maybe 18 minus 2. But that gives you 16. And we're supposed to be getting negative 6. So if you want to play around in your calculator that way, you can. Either way, the answer is D. All right. Let's look at 54. 54 says find the product. And you might think that we're subtracting because it looks like these are minus signs. But what's in between this negative 5 over 4 and this parentheses? It's kind of like a pretend multiply dot. So we're not subtracting these. We're just straight up multiplying. And we need to remember that a negative multiplied with a negative is equal to a positive. All right, let's go. So to multiply, we go left to right. 5 times 6 is 30. All over. 4 times 25 is 100. Okay, and then a negative times a negative is a plusative. And then let's reduce. I think you can reduce by 10. So you get 3 over 10. D. All right, let's look at 55. It says find the quotient. That just means divide. Okay, so you can put this in your calculator if you want. Or we can reduce if you want to. It doesn't matter. But either way, let's try reducing just by 5. If I reduce by 5, on the bottom, we get negative 1. On the top, let's see what 135 divided by 5 is. 27. And then, let's see here. What's a positive 27 divided by a negative 1? Well, definitely 27. Yeah. But a positive multiplied with a negative is always a negative. And vice versa. A positive divided by a negative is always negative. So anyway, my answer is negative 27 or D. Alright, let's go to 56. Find the quotient. That means divide again. Okay, well, it looks like we're dividing fractions. And when we divide fractions, we do keep, change, flip. So anytime you have a division symbol, or maybe you have like a backslash thing, or, you know, a number on top of another number. Anytime you have a number on top of a number, a number on top of another number, and you're dividing, you have to do keep, change, flip. Okay, so let's do it. We're going to keep 1 over 4. We're going to change the division dot to a multiply. We're going to flip this guy upside down. 6 over 5 with a negative. Yay. Okay, now how do we multiply? We go left to right. And we get negative 6 over 20. And then we can reduce by maybe 2. And we get negative 3 over 10. Hey, C. Meow. All right, let's do 57. It says evaluate the expression. This is kind of like 45. Where if we see the equal sign, that's like saying the word is. Okay, so this is saying x is -2 from now on. It's saying y is 3 from now on. And a is -4 from now on. Okay, well, it's time. Let's plug these numbers in. We're going to have -4, and then that a that's squished up right beside it, that's multiply. So, anytime we plug in a number, we put it in parentheses. So where this a is, I'm going to put whatever the a is, -4. Okay, then I write -6. Okay, so -6, parentheses, whatever the y is, 3. Then finish it, -8, parentheses, whatever x is, which is -2. Okay, now we're going to do PEMDAS. PEMDAS says you got to take care of the P, the E, the M. It does not say we need to take care of the addition and subtraction first. So we need to take care of the parentheses and the multiplying. So let's see here. -4 multiply -4, +16. For the next sucker, -6 times 3. -18. And then -8 times -2. And that makes +16. Okay, then we add it all up and subtract, and we get 32 minus 18, 22. I just hit my funny bone. I think we get 14. Yep, C. Woohoo! C. Okay, number 58. It says simplify the expression. Well, it's a trick because there's something missing. This is definitely -8 minus parentheses, blah, 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 blah. But it's like we're missing a 1. That's multiplying at the very front, to the left of this parentheses. So, if I want to do PEMDAS, PEMDAS says we have to take care of the P. Well, let's see. Can I subtract 7 and 3s? And the answer is no, because one of them has an s on it. Okay, so we can't do the P. There's no exponent. Oh, but there is multiply, that -1. So let's do it. What is this -1 multiplied with 7? And then again for -3s. So let's see. -1 multiplied with 7 is -7. -1 multiplied -3 is +3s. And then drop down that -8 from the very front. Okay, now combine like terms. Well, there ain't no other s besides this s, so I'm just writing it down. And then -8 minus 7 is -15. Hey, C. Woo. Uh-oh, almost done. 59, it says, give the numerical coefficient. Numerical means number. Coefficient means big number. Yeah. So the big number is -9. So D. Okay. Lastly, it says identify the group of terms as like or unlike. Okay. That means we look at the exponents. So we need to look at the tiny numbers to match. Okay, well, let's look at my tiny numbers. I have an 8 and a 9. Well, those don't match. So that means unlike. So who cares if the 19s at the front are the same? Nobody cares about that when we talk about like and unlike terms. We do not care about that number in the big number in front. We care about those tiny numbers and if they match, and they don't, so it's unlike. Yay!